Today's topic is Wi-Fi service assurance, and the issue with Wi-Fi service assurance is how to measure congestion and deliver quality. Uh, what's interesting about today in particular is that Wi-Fi has become so commonplace that it's so ubiquitous that it's become much more of a concern to us, even though it is ubiquitous. The fact is we expect it to just work like a utility. And what we want to talk about today is really how do you measure that manage it and deliver the utility or the capabilities that you'd like. All right, so this is the Wi-Fi landscape and architecture slide. And what I wanted to talk about here is overall, we're going to be talking about today critical IP services, which are one of our key use cases, measuring Wi-Fi quality and network congestion and service quality. And then finally, we're also going to be talking about troubleshooting individual subscriber experiences and real world examples. So this is, what we're talking about. I'm starting off with the landscape and the architecture. It's really to talk about what's happening in the Wi-Fi world today. And so what we're seeing is that the majority of traffic across, and what we're looking at here is U.S. Networks. The majority overall is over Wi-Fi. It's the dominant number of sessions, the most traffic, and the most usage when compared to mobile. And this is really surprising to me, but it really shouldn't be, because providers have taken the time to train me and my customers and my family to use Wi-Fi rather than the more costly mobile services. And so it's become a crucial technology, and it's basically an extension of the cellular network. And despite the fact that Wi-Fi is mostly free, consumers have started to look at Wi-Fi from a good quality and a bad quality. I mean, they know when it's bad. And the problem is when they use Wi-Fi to use the services that operators are providing, good or bad Wi-Fi impact their experience of the operator services. And they don't make a big differentiation between that, and we know that. And if we look at the types of applications that are going on here, the key applications are social, video streaming, browsing, etc. And you can see that and understand it. Facebook and YouTube are really the most popular. But the question you might want to ask yourself is, how do you make sure Facebook looks good? And how do you make sure YouTube goes well when they're both very different types of traffic, different applications? And how do you measure the quality and the delivery that you're doing? And that's really what we're going to be talking about today. We're going to talk about a number of the products we provide or the solutions we provide, but really in the context of how do we solve the problems that you have. So let's look at what the issues are today. Wi-Fi has truly come of age. 49% of total IP traffic by 2020 is going to be Wi-Fi, going over Wi-Fi, up from 42% in 2015. I mean, there was a time when gearheads such as myself would prefer, Ethernet. I really felt best plugging into walls. But now I haven't touched, an Ethernet jack in quite a while. Wi-Fi is just so simple. It's mobile, and it has become more and more dependable than in my office, in my home, and other places. I don't do anything hardware oriented. It's all over Wi-Fi. And so Wi-Fi plays many roles in the network. It is provided as offload for network operators. It provides access within enterprise, and is often the service or the access network of choice. And now it's the public space access as well. Most coffee shops now that I go to have it as well as airports and other places. But the challenges are that the quality of experience is difficult to maintain. The congestion management tools don't necessarily work across different systems, and the visibility into all aspects of service quality from end to end is generally not prevalent. or available. So there's really two different styles of Wi-Fi deployments that we're talking about. One is a decentralized one. And this is the one that I've probably most seen more of, and I would say is more prevalent around the world at this point, although these can shift. We'll talk about centralized next. But centralized would be something like a distributed airport solution. And this would be, if you're looking from left to right, the Wi-Fi APs and the Wi-Fi LAN controller and the site router and so forth. And the PSM and PRE are our products, but that's for traffic management and policy management. And that basically makes it so that we can shape the traffic, apply policies, and also do some of the analytics work and pass it on to our analytics engine, which is just to the right of that, which is called our PIC Insights product, our solution. But in this case, much of the infrastructure is really decentralized, and often the decentralized infrastructure will be virtualized. You don't necessarily want to have a full-out POP, a heavy-duty POP at every airport location or every type of organized place or location. Often, what you'd have is your access points, your Wi-Fi infrastructure, and a server or two running the policy and the traffic management side, a site router, and then you'd be pushing it off, that information, as well as getting your internet content through a centralized data center, a POP, which was showing here on the right. And so what you'd have is a number, let's say you covered dozens of airports. The airports, each one would have its own small infrastructure and its own traffic management, policy management, and collection devices. And then it would pass it on to the right, which would be a centralized center, which would be accessed and also provide internet access to all of these sites, all of these dozens of airport sites. Now, this is pretty simple from a cost point of view. It's economical, but from a management point of view, you have these dozens of sites. The analytics, the service assurance, the customer care, all of these aspects of running high-quality Wi-Fi are done and needed through these centralized POPs that will also use these analytics to identify where the problems are and if problems are occurring. Now, from a decentralized point or a centralized point of view, it's not all that different. Similar icons and so forth. But if you look to the left, you're seeing a different, let's say these are, this could be an office of some sort, or this could be enterprise campus where you have multiple offices with Wi-Fi traffic being tunneled to a central Wi-Fi LAN controller, wherein there is the policy management, the traffic management, your NATing devices, DHCP, DNS, and so forth, which are all centralized. And then you go back to the same analytics, the real-time visibility, customer care, and other aspects of managing your operations. This would be possibly at a single campus with multiple offices, buildings that it's supporting to a central POP. And this could also represent a converged provider who has tunnel traffic and is doing Wi-Fi as well as mobile as well as fixed, whatever the network access issues are. So let's go to the Wi-Fi service assurance technology enablers. And let me tell you what we see as our key enablers, but these are just necessary to provide appropriate Wi-Fi capabilities and quality. First, there's application awareness. And application awareness is needed so that you can identify specific apps or classes of apps that maybe need to be prioritized. So when there's congestion, what are you going to prioritize over others? what type of congestion it is could also be managed through some of the congestion management capabilities that are in um, our network intelligence devices, which can take congestion management, can shape different traffic, can make it so heavy users get access but can't overtake the network. And so that's another capability as far as being aware of the types of subscribers who are on the network, being able to control them, being able to work with them at an individual device, department, location basis. You could look at them by service plan, SLA. There's so much variation that we can provide and that needs to be provided to be able to look at uh, professional Wi-Fi users and make it so that it is, when I say professional, I'm talking about when you're looking at providing services in a professional, not necessarily just a free situation where it's highly distributed and not well managed. We're talking about providing services that customers may be paying for and that they're uh, looking for the capabilities of, if a device has problems, it needs to be troubleshooted. It needs to be identified where the location outages are. It needs to be able to track a given individual, possibly as they move through buildings. When a CEO is using devices in different places and it breaks in one place, his network access breaks in one place, you want to be able to identify where it was, what happened, what device he was using, and so forth. And then finally, we have a capability called Scorecard. It's a solution that provides the quality of experience scoring that helps you identify, okay, from a type of service point of view, whether it be web, video, downloading, social, uploading. What are the types of services that customers are using? What's the latency you're seeing for each service? How many packets get lost? How much throughput occurs? And then we roll that up into a score. So you'd be able to say, okay, for a given office or a given location, the quality of experience is high, particularly on the web side, but the video side is poor. Now, why is that? What's happening on the links? What's happening inside the buildings? And so that allows you to get a sort of a KPI of what's happening and then make some decisions from there. Now, what we're showing here is the grading of a network based on a QoE score. And I just talked about scorecard. And if you look over to the right, well, let's look at one particular access point. And it's a very top one. And I'm going to call it 3602I, because you can see that that's the very top, the last few numerals and alphanumeric numerals in that description. And it has a score, you can see that it's pretty light, but it has a score of 2.4339. And that's a score out of 5, which isn't very high. All right. So we look at that and we say, okay, the score is middling at best. This is overall over a certain period of time. You look at the number of clients that may be using that access point over a given period of time, and it's close to 15,000 clients. And then you're seeing a relatively low quality of experience score and a very high client count. So what's that telling you? One is that either you don't have enough APs there and you're having a lower score because too many people are hitting that single AP, or it just may mean that because there's some problem with that particular device itself. My take would be that it's overused. That's the first look from a higher level. And then if you go down lower and you start looking at APs that are across your entire network and you look at the scoring, at a given, you can see that this is for a particular time filter. This is a particular second or short period of time where you're looking at that particular access point, which is C3602I, and you'll see it has 858 clients. Its score is about 1.5356, about 1.5. And so its score is even lower than it was when we looked at it in a longer time frame. And so that's a problem child. And if you had a tech who was coming to look at that network and was trying to identify where are the 15, 20 APs I need to go work on. What are we going to do this week? They would absolutely look at that 3602. It's a really quick way of identifying where the problems are and what to fix next. And this actually is a continuation of what we were just talking about, where we have a QoE score, and we're looking at, on the left-hand side, we're looking at a time frame, and all these time frames are the same. And we see that the QoE score has dropped on October 21st, 23rd through, I think that's the 25th. And then we see, well, the subscriber count that it handles has dropped. It must be dropping more subscribers. The bits per second dropped. The packet loss spiked. So what we're seeing is there is a problem happening with this AP, this location. This could be a number of APs as well. So these are the types of analytics we provide or that are needed to be able to say, okay, we are providing high quality Wi-Fi, and if something breaks, we can quickly identify it. We can track it over a series of time or track it in real time and then go fix it. And here's just another view that we're providing here. What we're doing here is this is stats for the Wi-Fi over a period of days, and it's showing incoming connections on a per second, outgoing connections per second, established connections, and more. And what we're doing here is we're taking information from the Wi-Fi LAN controller and we're bringing it into our network intelligence, and we're using that as what we're calling decoration, where we're using that information and being able to compile it and look at it from live view, which is a view that we provide. It's a graphical user interface that we have that identifies, what AP we're talking about, the channels, the devices, frequency, SSIDs, all different types of dimensions of the product or of a unit or a location. And you can see here, if you look a little further down under by AP, you can see it's April 26th, April 25th, April 24th. And if you look over, you'll notice that there's 0 bits going through or on one day, and there's 124.5 bits, kilobytes per second going through on average in a given second. And what that identifies is that there's either those are days off where there's nobody there, or that there's ongoing problems with that AP. And so it's an obvious place to try to go fix. And then finally, not only do we identify, or not only is it required to identify all of these different analytics, but you also need to be able to do something with it. So you do the trend analysis. You also need alerts when there's some deviation from the trend and it exceeds a threshold. And you also then need to actually have built-in notifications that are triggered by these thresholds. We provide all of this, but these are these are capabilities that are required for you to identify problems, figure out how the problems are occurring over time, look at them versus trends, and also trigger actions when required. Now, I'm going to go to the 3 use cases now, and I'm going to cover the Wi-Fi, the critical IP services. When we talk about critical IP services, you can think DNS, DHCP, and Radius. These are those services that when you're in the airport, you just think about when you go to that airport and you try to get into the Wi-Fi, and you try 3 or 4 times you open up your browser, Yahoo or Google comes in, there's a redirect that happens. The portal then provides you with a logon, or there's some sort of Radius authentication, or it's a checkbox here. But how many times do you go into that browser and Google comes up and it just shows Google, or it says no connection available, and you try that 3 or 4 times and it works? Well, that's why we call it a critical IP service, because at some point, customers and your subscribers are not going to be able to get access, and they just don't use it. That's a bad experience, not being able to get access when they need it. And so those are the critical IP services, largely about getting on the network. And what you want is first time, every time, to be able to get access. In the perfect world, you'd like that to happen as often as possible, and as little drops as possible. And so this is an overview that I have here. This is how we sort of fit into a Wi-Fi network from a critical IP services point of view is we have several different products we're showing here. All the ones in blue from vertically in the center, PSM, Insights, LiveView, PRE. Those are our products. But in short, what they're doing is we're taking DHCP, radius, DNS feeds. We're identifying if there's errors or authentication problems. We look at timeouts. We score how the applications are working. We have device information. We have location information. We have RF information. So there's all different ways that we can look at any problems that occur. And then we can also monitor and provide diagnostic tools and reports that help with customer care, that provide graphical reports that just make it easier to identify what the problems are that occur. And then this is a similar situation, but what we're showing here is that what we're looking at is timeouts and what the different products that we have that are solutions that will measure and work with these issues. So what we need here is proactive monitoring of critical services. And what we're seeing is many large tier one operators who are providing the Wi-Fi capabilities don't necessarily have access or don't own the DHCP, radius, and DNS resources themselves. So they're overlaying network capabilities, but not really being able to control these critical IP services. So that makes it even more critical for them to be able to have the tools within their networks, within that network, to be able to identify if there's DHC, if any of these onboarding or these login issues occur. They may not own those services, but they would be able to, by tracking those services, trending them, monitoring, identifying where problems are, they'd be able to proactively go back to their enterprises and other types of customers with information saying, your login, your customers are not, your subscribers or your employees are logging in. They're dropping 7 or 10% of the time, which would be a real problem for them. And those subscribers, those employees, are going to look at it as the operator's problem or maybe the IT's problem that's in-house. So there could be a lot of finger pointing, but by having the right analytics tools in-house, you're going to be able to help mitigate that finger pointing. So in short, some of our key capabilities is detailed tracking of all of these critical IP services, correlation of response time to websites, to applications, to locations, and then all the views that we've been talking about. Now, this can be done in an appliance-based way or virtualized. We're completely transparent to us. We can, in each of these sites, we're very happy to put in a box that has our software on it. But if you want to go to a virtual environment, which more and more of our customers are, it equally works as well and scales extremely well to be able to put all of this capability virtualized in more generic boxes and place them throughout the network. And we're vendor agnostic. We can work with any Wi-Fi vendor and integrate with them and do all of this automated alerting, ticketing, and analysis we're talking about. And these are just a couple more views of the critical services. And what you're seeing is a spike that's on January 17th on average response time. So the average response time goes from 2.2 seconds to almost 2 seconds in this case. And then the quality of experience, this is critical IP services, this is DNS again, and what we're seeing at 10 o'clock on a given day or 10:30 across a number of, looks like subway stations or train stations, that there's a spike in the DNS average quality of handshake response time. So it's gone from 0 to about 2 seconds. So you're probably losing people and certainly not providing a good quality of experience. And what we're having is identifying a potential DNS outage across all the locations. And then this would be, post facto, after you identify these issues, these ongoing issues, you work on them. And this could be done, many different ways. But identify, the troubleshooting begins, after you start monitoring, identifying where the problems are, go on site and possibly. And then what you'll see is the average response time then can go down on the DNS side over time based on the responses you have, based on the insight that you've received. And then this is about my last slide on this use case, which is we also can give what we call heat maps, and these are by network locations. So in this case, we're seeing all that is green are working just fine, but all that is red is showing the difference between a 7 millisecond response time and an almost 1 second response time on DNS. So once again, this identifies, okay, here's some of the stations that are along that transportation line, and it looks like there's 3 or 4 that we need to work on immediately from a DNS point of view. And this is finally to give an idea that we can do response times by different domains. We can do it by applications, and this could help you identify that you have peering problems or other issues, within your broader network. And then finally, we can come up with a DHCP health report, and this is a real life case, so that's why some of this is blurred on the left hand side. But what we're seeing is that we're providing average scores here, and this is a case where what we're seeing is that the request timeout, meaning we're losing customers or subscribers 7% of the time, and this is the highest one. And so this location would be the one that would obviously be the one you probably most focus on relative to others. So this is one other metrics to look at. So I've shown many metrics. What I'm trying to get across here is that we provide you with the opportunity to troubleshoot critical services as well as other types of Wi-Fi quality problems, in detailed fashion that allows you to go out and fix them, accordingly and most effectively. Now I'm going to pass this on to Thomas Vassad, my colleague, who's going to talk about the next couple of use cases and also some customer examples.
Thank you, Dan. Can you hear me okay?
I can.
Perfect. So before I continue with a few more of our live use cases around managing the quality of experience in Wi-Fi networks, I would like to address one of the questions being posted on the forum about where the quality of experience score comes from. And this comes indeed from our scorecard solution that measures the quality of all IP traffic all the time for every subscriber at a very high granularity. So what we do is we look at individual flows and measure the throughput being delivered every 256 milliseconds, so that we really see what peaks of throughput the network is delivering to the subscriber. And we add in the mix then packet loss and round trip times, latency, and calculate a score from different applications perspectives. Our insight solution, the other side of the coin, is focusing on the application awareness, understanding what apps are being used. So with that in mind, if there's any more questions, please don't hesitate to type them into the webinar panel. We'll try to address them during the call, or otherwise we'll come back to you afterwards. Great. So I'm going to focus on a few use cases. The first one being basic visibility. So customers really want to understand what their networks are being used for, and we provide that type of reporting by top applications, by quality, and also by quality of experience for those applications. It is critical to understand what's popular, what you should promote and who you should partner with, but also to understand if there are any abnormalities in your network usage. Perhaps there are some network threats or some applications that tend to take oversight of the type of the bandwidth that's available. I think everybody has that experience when you go into a public Wi-Fi area or at a conference, and it might work in the beginning of the morning, and then during when it gets closer to lunch, everything sort of stops because it's just too many users on the network, and they're all using non-critical services. this type of visibility gives you insights into what type of services are being used and what could I possibly shape in order to maximize the experience for everybody on the network. Obviously, this type of information is available with trends and over time as well. The second use case is diagnostics and preventative care. So this graph here shows you the quality of experience that is being monitored over time. What we see there is that I know that there in the end, when the service started to degrade a little bit, I know that some of the APs have been upgraded with new firmware. And the interesting part about this is that the degradation in quality is actually so little that it's barely noticed by customer support or any other factors. Customers use this Wi-Fi service, are probably a bit less happy, but don't go and complain until all of a sudden there's a spike in usage there and a negative spike in quality. And this is when there's a certain weather situation, a lot of users are coming onto the network, and all of a sudden the network doesn't cope anymore. The new firmware is actually causing a problem here. So the key thing here is that if you keep your tabs on your different dimensions in your network, so compare all the APs and slice them down in different firmware groups as well to monitor any abnormalities, any deviations, any trends, then you can take proactive action. You see what the effect of your maintenance is immediately afterwards. You monitor it, and you can take actual action based upon real traffic. So I'm going to try the next slide. And the next use case is focusing on what the subscriber does, doing advanced analytics in order to understand what's popular and also enable monetization of that type of information. So imagine that you can see in an airport, for instance, how people are moving around inside the airport, what stores they are walking by, what gates they're pausing at, and then what restaurants they see. And while they're doing that, you can see what type of applications they use and what type of content they are looking at a non-intrusive level, of course. This enables type of customer profiling to understand what kind of habits they have. It can help you place products in the right locations, and it helps you to create upsell opportunities specific towards services, towards subscribers, and be relevant towards them. This can be relevant in a commercial perspective, but also in a private perspective when it's employees or student locations, in order to serve them better with information that is needed for them. There's a little bit delay in changing the slides here, but it's coming right up, I think. Here we dive a little bit deeper. Yeah, maybe I can change for me then. Yeah, here we dive a little bit deeper into the network service assurance case. So the normal QoE trend over days is monitored here by access point. The enrichment that Dan explained is key here. So our enrichment service is continuously monitoring signaling changes and log files from the wireless access point controllers, and retrieving that information and adding that in real time to every flow detected in the network. When every flow is decorated or enriched with this type of information, we can now see the source of the flow and then group them together. So when we measure metrics such as QoE, we can find commonalities by what the likely cause of this QoE deviations is. So here you see that there's a certain amount of access points that are upgraded, and we can see that the quality is degrading a bit. It's going 10th of a percentage point down, or 2 of them even, but it's not severely impacted until 2-3 days later, when the volume of customers is much larger on this network. So with this type of tool, the outage could have been detected much earlier. You could have done it more carefully by upgrading only a part of your access points and monitor those separately and compare them towards each other, and with that avoid any degradation in the service. Maybe you can advance to the next slide then. Here is a second example, more focused around SLA monitoring. We can see here that there's a general SLA trend in quality, and then a certain specific date there's an outage in this part of the network where the number of subscribers is increasing, but the average throughput is significantly decreasing. This type of tools can keep tabs on what's actually happening and how and who is impacted by this type of outages. Of course, it is critical to look at locations when looking at a Wi-Fi situation. And as I said, we enrich every flow with information from the wireless LAN controller, and then we add to the flows what access point the location came from, the flow came from, so that we can tie the flows together and find commonalities in quality. We can display that in a map like this. So here you see a number of access points in a building, in a location. And the size of them is the number of subscribers attached to them, or the volume of traffic that is flowing through them. And then the color is the score of the quality. So the greener the better, but all of them are pretty green here, so there's not too much trouble in this network right now. We can also enrich every flow with information from the wireless LAN controller, being, for instance, the signal-to-noise ratio that's being measured on that particular connection. And when you do that, you find very direct correlations between the score measured on the traffic throughput and loss and latency, as well as the signal-to-noise ratio delivered to that client. Moving to the next slide. Thank you, Dan. We pulled this all together in an overview health dashboard, where this is live updated or with very short intervals, and you see here the overall usage of the network in terms of subscribers attached and throughput delivered, down and up, and you see how many of the access points that are being monitored are having live traffic. And if you click on any of these tiles, you dive deeper into that dimension. Oh, please go back one slide. Yeah. The third tile will show you what services are being used and being and for how much, and the fourth will show you the quality of experience being delivered. We also slice this by SSID to see the division between your networks as such, and by wireless LAN controller. And finally, a top-level tile on the critical services that Dan went through, here being DHCP. So if we go to the next slide, the data allows us to build very powerful comparative performance ranking reports, where here you see over time, week by week, access points, and between those access points, the volume of traffic and the quality being delivered. So number of clients attached, as well as the volume of traffic being taken care of, and then in the color, the score, from green being good and red being bad. I think it's pretty clear on this sheet what access points are most congested and should be taken care of to spread out the traffic a little bit more and increase the experience for all the subscribers in that location. Now, next slide, please. If you dive deeper into what applications are being used, you get very interesting scenarios, and this is looking from an airport perspective. A certain time of day when a lot of flights are leaving, the orange bar there is actually showing iTunes or Netflix downloads. I think it's Netflix downloads. So people want to, of course, view some of the movies and series while they are on the plane. You can now follow these spikes and also see what services are being valued by what subscribers in what locations. And from a network perspective, you can see the interconnect routers performance, also split up by service if you need to. So going back to some of Procera's unique capabilities, Procera focuses on providing visibility by providing several channels, either do it live and through real-time customer portals so that you can act immediately upon what you see and troubleshoot your network. Statistical viewer to provide a historical perspective, and insights and third-party dashboards to allow drill down and do real analytical behavior analysis to understand, for instance, the customer's profile, etc. We also provide raw data export if you want to ship out IPFix towards your big data system in real time, or do SQL queries, or just comma separated file exports. It's all possible. The solutions that we provide, they could be appliance-based, but increasingly more often they're all virtual, and for us that makes no difference. The same performance and functionality in both scenarios. And you can even mix and match that type of deployment. And you can either do centralized or decentralized, as Dan explained. If you manage an airport, maybe you want to have a controller and a network intelligence probe close by every location, but you centralize the management of those. But the other way around, if you have 10 to 100 coffee shops in a certain city, maybe you backhaul all the traffic to a central location, and then you can place the network intelligence probe there. Our solution is vendor agnostic. We can integrate with any Wi-Fi vendor and access point vendor. We have successfully done so with quite many already. We allow the possibility to integrate automatic alerts and generate trouble tickets, as an example. The per subscriber scoring and the addition of the geolocation quality of service views are really helpful to expose hotspots and trouble areas and holes in your network. And from an application perspective, our signature database with over 3,000 applications and weekly updates helps you stay on top of new application trends, so you never be blind and behind. And to increase the customer's experience, we offer fair split shaping strategies to actually balance applications between each other, or customers in a fair way, so that everybody gets an equal slice of the network. If we move on one or two slides, we just want to highlight a couple of ways to troubleshoot an individual subscriber as well. Wi-Fi networks really need to focus on getting better visibility around the problems, and there are really 4 metrics that are important. It's connectivity, it's application performance, it's network KPIs, and the radio environment. So the reason why we would want to do that is to look for ways to save money and make money. Save money in terms of reduce churn by proactively monitoring, or finding ways to be operationally more efficient, increase first call resolution and decrease time to resolution, or empower operators to make much better informed decisions about where to invest money to increase the quality of experience, but also enables you to make money to figure out what kind of value-added services receive good uptake, and how can I increase the experience to increase the data consumption. And lastly, but not least, identify what kind of packages can be introduced to offer a premium service plan solution. Doing this with KPIs, monitoring on the subscriber experience solution, it's really about logging every DHCP transaction, every radius transaction, and every DNS query. It's those three together that combine the critical services and measure the connectivity perspective. But on top of that, it is important to score from a different application perspective, and to provide visibility into what device is used, what operating system is used, what web browser is used, what software versions is used on the client's devices as well. This is critical because a lot of the problems might actually originate by whatever type of device or firmware it is. What we are able to do is to, even on the Wi-Fi network, understand and tag the traffic with what devices they are. And the way we do that is with a technology called device pinning. That is that we track some of the devices usage, for instance, a connection to an iTunes store or an app store, and from there can see, oh, this is that type of device, and then afterwards we can track any other traffic also to that device type, and we can actually correlate quality on other traffic, but still categorize it by device and device type. Last but not least, the characteristics of a user's RF environment is really critical to be added to this mix by retrieving it from the wireless LAN controller. Yes, so those different applications work like this. The live view lets you dive in real time into the traffic in a 5-second interval, see exactly what's going on, immediately split out into all the different dimensions that I mentioned. Customer Care Insights is looking at a post view, but at a subscriber of one type of experience to really help customer care agents to resolve tickets quickly. When they have them on the phone, you can really immediately acknowledge this. Yes, sir. Yes, madam. I see that you had a recent outage, and I apologize. Let me help you fix this. And from a trending and a scoring perspective, we offer Tableau connectivity towards an ODBC database to look at 5-minute aggregate data on traffic in the network. When you dive into an individual subscriber, then you can actually look at their behavior and their traffic usage. You can see here we're tracking an individual subscriber. They connect their iPad at a certain location in the airport, and they move around. They use a little bit of traffic, probably downloading a movie or some sort, and then they enter the lounge. They are attached to a new access point, and at this access point, throughput almost drops to 0. So there's a real bad experience here for this premium subscriber, and it's not until he changes the SSID that he reverts to the original gateway and runs better quality again. So this helps you identify immediately that the handover there in the area of the lounge is not working and should be fixed. I went a little bit too quick there. And here you have a final view of troubleshooting individual subscriber, that we can see all the services that are being used by that subscriber over time, so that we can help that user identify what the problems are, and if they are unique in this, or if other subscribers have similar traffic problems. This type of stuff is done with seconds granularity, so it's real accurate about how much each service is consuming and performing. So before we leave you for today, we wanted to give you a couple of real life examples about who is using this type of thing. And one of our oldest customers on a virtualized environment is Boingo Wireless, of course, famous Wi-Fi provider in all over the world, but very present in the US in airports and stations and military bases, etc. In their challenge was to get better real-time business insights in order to offer better control and enhance the experiences, but also to help monetize the network in a way that was not able to be done before. And if I go to the next slide here, you can see the way that we deployed here is in a decentralized mode, so that every airport or military base or of the sorts has a virtual infrastructure appliance. And inside this appliance, there's a lot of Boingo magic on top of a standard Dell 720 server, a VMware hypervisor. There is a controller, there are network and translation services, DHCP services, IPTV proxy, lots of the stuff that they need to provide a good service. And then on top of that, there's the Procera DPI traffic management network intelligence probe that is actively installed in the network in order to both provide intelligence feeds and to perform traffic shaping and policy control use cases. There are hundreds, if not thousands, of those via CPE engines, virtual infrastructure appliances deployed throughout Boingo's network, and they all report back and are orchestrated by a centralized cloud-based provisioning solution hosted in Amazon EC2. And this is where the analytics solution resides, the dashboards are run from, and subscriber management and enrichment is being controlled from as well. But of course, the subscriber management controller needs to query each of the wireless access point controllers in the locations in order to get that insights about what AP has what subscriber with what SNI with what type of characteristics. And a last example here is a solution run by a different provider, also hosted on by many public locations, running fully virtual, doing proactive quality of service monitoring in different types of deployments, with integration tight with the access point controllers. And the key values here are to secure quality, provide diagnostics capability, and with that provide quick resolution and a higher experience to promote brand loyalty. It is to improve the network uptime and the service assurance, and to provide insights to third parties about what's happening in the network. If we look at a stadium example here, then we see there are thousands of hotspots typically deployed in a large stadium like this, and we monitor each and every one individually and can monitor the key services and the traffic flows by the subscribers inside them. So I think with that we're almost done, and I would like to hand over to Dan to just give some final words. Dan, you're muted still.
I sure was. Thank you, Thomas. We've covered quite a bit on the analytics front, quality of service today, and the ins and outs of Wi-Fi, as well as some of the technologies that we enable to provide those capabilities that we're looking for from a quality point of view. From that, we're going to be doing a couple things. We'll send out an email today, and in that email will be a link to our Wi-Fi service assurance solution brief, which will outline what we've talked about today. That's probably under our resources section of our website right now. And then we'll have a recording of this webinar, which we'll also forward you a link to, which you'll be able to access in your own time or provide to others. And finally, this is an ongoing series of seminars and webinars on different aspects of packet intelligence. And our next one's going to be on May 24th. That's just 2 weeks from today. All of you here who have already signed up are signed up for them in the future as well. You just have to show up, and they should be in your daytimers already. The next one is going to be on big data network analytics, and we have some really interesting use cases and frameworks to show what's happening from a big data network analytics point of view. Once again, this is around providing better services and customer experience. Yet what we're doing here is also using big data in multiple situations, be it for marketing, be it for network performance, be it for KPIs around customer experience. There's many different ways that customers are using the data that we provide to run their businesses better. So on that note, I'd like to thank all of you for joining us. Thanks for your help today as well, Thomas. And good day and good evening to all of you.
Thank you. Goodbye.